Good evening, everyone. Thank you so much for tuning in. We're going to go ahead and give it just a couple more minutes to allow some attendees to continue to trickle in. But again, thank you so much for being on time, and we'll be with you to kick this off in just a minute. Good evening once again, everybody. Hi there. My name is Ian Latimer. I'm a project manager on NYSERDA's Clean Energy Siting team. And it's my sincere pleasure to welcome you all to the third event in NYSERDA's ongoing webinar series entitled Battery Energy Storage Systems, Key Considerations for Local Governments. As you can see on screen, tonight's webinar number 3 is focused on permitting and zoning, a couple of key concerns of local governments across the state. So again, my sincere thanks to you for joining us tonight. As you all know, or are soon to know, if you haven't tuned into the previous events in this series, energy storage is an exciting and growing piece of New York's energy landscape. So it's great to have you all with us to learn about this important technology. And next slide, please. Just going to go over a few housekeeping considerations before we kick off this evening's webinar. All of the attendees have been placed in listen-only mode. You've been muted upon entry, and you'll see that there's a little icon indicating that your microphone is muted. You'll note that on the right in the WebEx control panel. We really would love all of the attendees to submit questions and comments at any time throughout the event using the Q&A feature. If you want to take a moment to locate the Q&A feature so that you can write your questions and comments as we go, that would be wonderful. To that effect, if you have a question or a comment pertaining to something on a particular slide, you'll notice that there are slide numbers on the bottom right-hand corner of each slide. Please feel free to indicate that slide so that we know exactly where to refer your question or comment to during the Q&A portion later in the webinar. The chat feature is disabled, so the Q&A function is your best bet for submitting questions and answers. Recording of today's webinar will be posted on our website at www.nyserda.ny.gov/storage guidebook. From there, you're able to click a link that will take you to the Battery Energy Storage Systems Trainings for Local Governments page, which has the recordings from each of the previous webinars in this series, and we'll end up having all of them in a few weeks once we wrap this series up. Additionally, if any technical problems arise, please feel free to reach out to my colleague Sal. His email there is there on screen. It's sal.graven@nyserda.ny.gov if you're having any technical issues. Otherwise, we should be all set. And we'll go to the next slide, please. One final item before we begin tonight's presentation. Just want to give a quick preview of the coming and remaining webinars in our series. A couple weeks from now, we'll be focusing on decommissioning and end-of-life considerations, featuring great outside speakers from DNV and Lifecycle to talk about decommissioning and recycling of energy storage systems. And finally, rounding out our 5-part webinar series will be a session on taxation and assessments on Wednesday, June 30th. We're pleased to welcome speakers from Hodgson Russ, who will be taking us through that session. So we sincerely hope that you stick around for the rest of the webinars in this series. You should be able to register for those using the same links or from the same place that you were able to register for tonight's session and any previous sessions as well. Next slide, please. A quick agenda for what we'll be covering in tonight's session. We'll start with a brief recap covering energy storage in New York State, as well as material covered in the previous webinars. We'll talk briefly, or from there, we'll go ahead and turn to the Energy Storage Guidebook for Local Governments, which is NYSERDA's primary resource for local governments on battery energy storage systems. We'll go through each of the components, including the model zoning law, the model permit and inspection checklist for residential and small commercial energy storage systems. Finally, the 2020 New York State Uniform Code requirements for battery energy storage systems. Following that, we'll have a Q&A with our presenters. And speaking of our presenters, I am very happy to announce my colleagues of the Clean Energy Siting team. Given that this is a NYSERDA resource, who better to walk us through it than the folks who administer the resource. So I'm pleased to we'll start out with my colleague Jennifer Manier, who's the program manager for the Clean Energy Siting team. Following Jen's presentation, you'll be hearing from my colleague Candace Rossi, who's a project manager on both the siting team as well as the New York Sun team, which administers the solar incentive program for NYSERDA for DER solar. And finally, we'll be hearing from my colleague Bill Obercare, a project manager on the Clean Energy Siting team as well. But before we get to my colleagues, I'm going to go ahead and take us through to the next slide, please, where we'll cover a brief recap on energy storage in New York State, as well as the material covered in the 2 webinars prior to this session. What better place to start than with the Climate Leadership and Community Protection Act, also known as the CLCPA or the Climate Act. The Climate Act was signed into law in 2019. It's a nation-leading piece of legislation which demonstrates New York's commitment to fighting climate change, transforming our economy, and building resilient communities. Now, the key thing to keep in mind with the Climate Act is that it's very prescriptive in terms of a number of goals that New York State needs to hit in the coming years. Primarily, we'll focus here on the left side, electricity sector goals, which are that we need to hit 70% renewable electricity by 2030 and 100% emissions-free grid by 2040. Now, most estimates put us at around a 27 to 28% renewable currently, so you can see that we have a ways to go before we hit that 70% number by 2030. In addition to these electricity sector-wide goals, there's a number of technology-specific goals that we're going to need to hit, which will take us on that path to 70% by 2030. Up first is 6,000 megawatts of distributed solar, meaning everything from rooftop to community solar scale projects by 2025. An additional 9,000 megawatts of offshore wind by 2035. And finally, the energy storage goals, which are to hit 1,500 megawatts of storage by 2025 and 3,000 megawatts, doubling that figure, by 2030. Now, energy storage goals, as included in the Climate Act, were calibrated based on the original CES or Clean Energy Standard goals of 50% by 2030. So it's likely that energy storage needs to ensure the penetration of intermittent renewable resources will need to be increasingly more than 1,500 megawatts and 3,000 megawatts. But those are the goals included under the Climate Act. Next slide, please. Now, for a quick intro to energy storage systems, for those of us who maybe didn't catch the last couple of webinars in our series, we'll just touch on these briefly. Energy storage systems are, like their name says, they're storing energy for conversion to electrical energy. And primarily what we're talking about here are going to be batteries, which are going to be storing chemical or electrochemical energy and turning it into electrical energy. These are the most common and flexible types of energy storage systems as compared to things like flywheels or hydroelectric energy storage. So batteries will be the primary focus of this and the remaining webinars in the series. And specifically, lithium-ion battery chemistries are the prevailing chemistries for energy storage systems for both residential, through commercial, through large-scale use. Lithium-ion batteries are the primary tool in electrochemistry that we see used today. Now, when we talk about an energy storage system, to zoom in really small, the building blocks are going to be the cells. So battery cells, which are going to be similar to the lithium-ion battery cells that you'll find in, a cell phone or a laptop. Same idea. And when you string those cells together, you'll get what's known as a module. And when you string those modules together, you get what's known as a rack. And a number of racks can lead up to a large energy storage system. And so you get everything from residential applications, like we see in the middle top photo, which is going to be in the kilowatt hour range, and it's going to be used to provide on-site power at a residence. You'll also have commercial applications, which are going to be providing similar services, but for commercial operations. And those are usually going to be in the kilowatt hour to megawatt hour range. And then finally, we have utility scale or bulk storage, which is going to be in the megawatt hour to gigawatt hour range. In addition to the cells, modules, and racks, we also have other system equipment, including the battery management system, which is a sophisticated piece of technology, which basically acts as the brains, the eyes, and the ears of your battery system to ensure that it's operating within normal parameters and that you're mitigating any safety or fire risks. And then finally, there's monitoring safety and balance of system equipment, again, to ensure that operations will be smooth sailing. Next slide, please. Now, I just want to hit on a couple of use cases for energy storage, which can give you an idea of why, we envision energy storage playing a significant role in New York State's clean energy landscape. There's a few different reasons, and you can see sort of where energy storage slots into this diagram when it comes to charging from power plants and intermittent renewable sources and providing power. That's sort of the most obvious use for energy storage, but there are others, including deferring costly upgrades to transmission and distribution infrastructure. As many of you probably know, the price tag when it comes to upgrading grid infrastructure is quite significant. And so if energy storage has a way of decreasing the burden on ratepayers of the costly upgrades to infrastructure, well, that seems like a great thing to do. Batteries can also provide key ancillary grid services to ensure that the grid is operating smoothly and in a stable manner. As I said before, it can support the integration of renewable energy generators, including solar and wind resources. It can also alleviate congestion in the grid by having targeted applications of batteries in places where the grid experiences the most congestion, and that can help alleviate brownouts and blackouts. And then finally, it can help with electric bill management and providing backup power for homes and businesses, whether that is, specifically charging with your solar that's on your roof during the day so that you can then use that power during the evening when costs are higher, things like that. Next slide, please. To support the rollout of energy storage across New York State, NYSERDA does have an energy storage incentive program, which is administering incentives as what we call the retail energy storage incentive, as well as the bulk energy storage incentive. The retail incentive is applicable for residential through commercial scale storage projects less than 5 megawatts in size. And the incentives will vary based on the region and the megawatt hour block allocation when you submit the project. We have already allocated over $161 million through the retail program, with an additional $16 million remaining for residential and commercial projects, specifically on Long Island and Con Edison territories. For the bulk storage incentives, that's going to be for the projects that are over 5 megawatts and providing grid benefits. Pardon me. Those incentives also vary based on the project size and the year of interconnection, and funding for the bulk energy storage program is currently fully allocated. Any updates to that will be announced through the energy storage program. Next slide, please. And this map will give you an idea of energy storage deployment in New York State to date. So as of October 31st, 2020, we had around 97 megawatts of installed capacity comprising 561 projects across the state. There's an additional significant amount in the pipeline, which we look at through the utility interconnection queues. And as of April 30th, 2021, there was an additional 1,027 megawatts, which is contracted and under development, comprising over 100 commercial and bulk energy storage projects. Next slide, please. And this is the final recap, and this will cover some of the material that we talked about in the last webinar on fire safety. Just a couple of key takeaways regarding the fire safety concern of energy storage systems. The primary consideration here will be the update and evolution of codes and standards for energy storage systems, which we will be talking about more later on this evening with my colleague Bill. The idea here to keep in mind, though, is that requirements for energy storage systems have evolved with the technology through the updated codes and standards, and that there are robust requirements already in place for local governments under the 2020 New York State Uniform Code, which is automatically applicable without local adoption in most of New York State. So there is a base layer of protections already built in for local code enforcement officials. The important thing is just to make sure that your code enforcement officials and inspectors are well trained on this issue, and we will again be covering some of that material tonight. We also talked about fire testing, which is to say that systems are required to complete large-scale fire testing in many cases to ensure installation safety. And that's going to give us a good idea of if something were to happen with these energy storage facilities, how can we respond? How can we design these installations in a way to ensure safety as the utmost priority? And finally, before I hand it off to my colleague, just want to plug, we again are working with the New York State Office of Fire Prevention and Control, as well as subject matter experts, to ensure that we can put together training and information to reach critical audiences, meaning our first responders. And that is something that we are really excited to get on the books because this is a critical need for local governments and first responders across New York State. And with that, we'll go to the next slide, please. And I am very pleased again to hand this off to our program manager for clean energy siting, Jennifer Manier, who's going to go ahead and walk us through the model zoning law. Jen, it's all yours.
Awesome. Thank you, Ian. Super excited to take you folks through some of the components of our model zoning law tonight. We're not going to get into every single detail of it. We have, we can meet up with you and do a 2-hour presentation just on the zoning law, but I'm going to do my best to touch on what I think are the highlights and the most critical take-home pieces. So before we get into it, just a brief high-level overview of the regulatory framework for permitting clean energy projects in the state in general. I think it's helpful to understand perhaps how energy storage differs a bit from renewable energy generation like solar and wind. So for solar and wind projects, any project that's under 25 megawatts is going to be permitted at the local level according to SEQR, State Environmental Quality Review, and any additional municipal requirements there might be. Projects that are larger than 25 megawatts are going to be permitted at the state level, either through Article 10 or through the new Office of Renewable Energy Siting, or ORES. And since ORES was established, there's this interesting thing where projects between 20 and 25 can choose to opt in to the state level siting process instead of going through the local level. So for solar and wind projects, it's really based on the size of the system where they're permitted. For energy storage, it's a little bit different. For energy storage projects that are paired or co-located with some of those large-scale renewable generation sources, they'd be permitted at the state level right along with that solar or wind project they're associated with. Projects that are not paired with large-scale renewable generators are going to be permitted at the local level, regardless of their size. So helpful to understand that. So a little bit about our energy storage model law. If you're familiar with our model solar law, it's very similar. It serves as what we think is a comprehensive template, which is also entirely customizable. It's all take it or leave it. We recommend it, but of course you're free to do with it as you see fit. We think it covers pretty much everything that you would want to see in a model law, from procedural things to substantive requirements for battery energy storage systems. It addresses systems of all different sizes and use cases, residential, commercial, utility scale, the whole gamut. It also reflects the process for compliance with SEQR. And like I briefly mentioned a second ago, municipalities are encouraged to modify it as needed or appropriate based on local priorities, concerns, and zoning. If you have any questions about what you maybe should or should not modify, we're always happy to do a review of your draft model law and provide feedback that is, again, you know, take it or leave it, just our opinion, but we're happy to help walk you through every step of the way. And last but not least, prior to undertaking the development of pretty much any law, but especially these ones, it's important to make sure that your comprehensive plan is up to date, because any zoning law that you adopt must be in accordance with a comprehensive plan. So if you don't have one, step one actually might be developing and adopting a comprehensive plan, or perhaps if it's old, updating it, and then start working on model law. And we're happy to help with that as well. So we are not going to go through every section of the model law in detail tonight, but it's helpful to at least know what's in there. Again, we think it's pretty comprehensive. You can see here it runs the whole gamut of the authority. There's definitions. Section 6 and 7, I think, are some of the more meat of it that you'll be the most interested in, the different permitting requirements for energy storage systems based on their size, and so on. So in section 1, like I said, it just sort of outlines the statutes upon which local government has the authority to implement the law. You're authorized to adopt these laws because they contain provisions that advance and protect the health, safety, and welfare of your community. And if you notice these gray highlighted and bracketed sections on the screen right now, you'll see that throughout the model law. And what that means is you should edit this section, absolutely. Like fill in the name of your village, town, or city, or in the case of the bolded section in the middle there, you know, delete the laws that don't apply to your particular type of municipality. Like I said before, it's still totally customizable. Those bracketed sections are where you absolutely should update it, but nothing is out of the realm of changing it if you see fit. We have it available in Word format, so it's totally customizable. Section 2 here, the statement of purpose. This is, you know, we just suggest these statements of purpose. You may want to add or remove these depending on what sorts of language you might have in your comprehensive plan. You want these to align well so that it makes sure that your law has some teeth. And again, you'll see some sections here where we recommend customizing it. Of course, fill in your village, town, city. And you'll notice on letter D at the bottom there, please, you know, include other stated goals that your community has according to the comp plan. And that doesn't necessarily mean that you have to keep A, B, and C, but if you like them, we hope you do. The key takeaways here, of course, it should reflect your local priorities and concerns. Of course, these vary by community. New York is a very diverse state. We know because our team travels around and talks to all of the different cities, towns, and villages and counties across the state and have seen it firsthand. They're all unique. And we'd also encourage trying to align it with not just your local, but perhaps county, regional, and state goals as well. Okay, so in section 3, we have some definitions here. This is actually a fairly important section. It distinguishes the cutoff between the different battery energy storage system sizes and what sort of permitting requirements are going to pertain to them. So we've cut them into 2 different tiers. Tier 1 being any battery energy storage system that has an aggregate energy capacity less than or equal to 600 kilowatt hours. And if it's in a room or enclosed area, it should only contain one single energy storage system technology. Basically, anything that does not fit that definition ends up in tier 2. So any system greater than 600 kilowatt hours, or if you have more than one type of storage battery technology in a room or enclosed area, you'll want to have stricter requirements for those because you want to be sure that the different battery technologies are not going to adversely interact with one another. I think you saw some similar pictures to these earlier, but these are just examples of tier 1 energy storage systems. The first one there just being a typical residential system, and then the 2 on the right look to be more of like mid to large size commercial installation. So we're going from 13 kilowatt hours to 250 kilowatt hours, 232 kilowatt hours, just to give you a sense of scale. And that first one there, the Tesla on the wall, the residential system, it's probably about the size of like a large suitcase versus the 2 on the right are maybe a couple refrigerators stuck together just for some scale. some examples of tier 2 energy storage systems here. The first one is 940 kilowatt hours. So that's just above that cutoff for tier 2, right? It's just a few hundred kilowatt hours more. And over on the right-hand side, a very large utility scale system. We're not sure what the exact megawatt hours for this one is, but it's a 20 megawatt system. I would guess it's somewhere in the ballpark of 80 megawatt hours. They tend to be 4-hour systems, but it can totally vary, so it's hard to say. But if that were the case, this might be an 80,000 kilowatt hour system compared to the one on the left that's 940. So they can greatly vary in size and scale. Okay, so in section 5 of the model law is the general requirements, and these are the types of things that apply to all systems regardless of size. So these are going to apply to tier 1, they're going to apply to tier 2. All of those systems are going to need a building permit and an electrical permit and be subject to seeker review. Some of the items you'll see here, like in letter C, which discuss the applicability of the Uniform Code, would be required even without you adopting a law because it's a statewide code, but it's still good to include this stuff to make sure that you're covering all of your bases and that everything someone needs to know to permit a system in your community is all in one place. It makes everyone's life easier. So key takeaways for here. Establish your baseline requirements for energy storage systems, regardless of size, and make sure that they align with seeker, the Uniform Code, and any other applicable codes and standards you may have on the books. Okay, moving on to the fun part. Section 6 and 7 of the model law, which are the permitting requirements for tier 1 and the permitting requirements for tier 2. So for tier 1, those smaller residential and commercial systems, we recommend using our battery energy storage system permit, which you'll hear a little bit more about it later, but it's very akin to the uniform solar permit, which has been around for many years and is widely adopted across the state. So if you're familiar with that, when you see the energy storage system permit, it's going to look very much like that and be familiar. We recommend that these smaller systems are exempt from site plan review. It's not really necessary. They're not taking up a lot of space or, affecting anything like that. And we also recommend allowing them in all zoning districts. They're really not going to be a problem and they can provide a valuable service to the buildings that they're serving. Section 7, this is going to be probably the biggest section of the model law and the most interesting for those tier 2 systems, which are much larger. And if you participated in one of the previous webinars we had about fire safety, you might have an understanding now of why we need to have more requirements on these larger systems. So for tier 2, we recommend going through a special use permit as well as site plan review and choose the zoning districts that you want these to be allowable in. Okay, so getting right into this, the fun stuff for tier 2, the permitting requirements. The model law goes through every permitting requirement that you might think of. Over on the right-hand side, and we're not going to go through every one of these in detail, but just take a moment to note what's in there. It's covering everything, utility lines, whether or not you should bury them, what kind of signage you can have on site, what kind of lighting is appropriate for these systems. You don't want it to look like a ballpark in the middle of the night. You want to keep the lighting to the bare minimum for safety. Vegetation and tree cutting. You want to minimize tree cutting, right, to the extent possible for any of these. We like trees. But you also want to make sure that you don't have too much vegetation nearby that it could possibly catch fire if something went wrong, and so on. Over on the left-hand side of the screen, which is actually an expanded version of the first requirement, which would be letter A, it's the process for approval. So you're laying out a clear process for how folks can go about getting these systems permitted. You're, in some cases, holding yourself to a reasonable review period. We suggest 10 business days. Maybe you want to change that. Maybe you need 15, a little more, a little less. Again, customizable. We recommend having tier 2 systems be subject to a public hearing that's publicly noticed. In some cases, you may need to refer to the county planning department pursuant to general municipal law. And again, after the public hearing, we just recommend 62 days to take action on the application. It's not in brackets, but again, you can edit that as you see fit. So I'm going to take you through just a couple of the requirements on the right-hand side in a little bit more detail. Again, not all of them. So one of the ones that we think is pretty important to discuss up front is decommissioning. We get a lot of questions. All right, so the developer puts this big energy storage system in our community, batteries, they don't last forever. What happens when the system reaches the end of its useful life? Who's responsible for removing it and disposing of it properly? So before even permitting it, you want to make sure that the developer or the system owner has submitted an appropriate decommissioning plan. It would include a narrative description of how they're going to go about removing the system and disposing of it, how long they actually expect it to last, how much they expect it to cost to decommission and remove it, and a description of those activities that go into it. And on top of that, we recommend, and this is just a screenshot of what's in the law there, we recommend requiring a decommissioning fund as well. On the off chance that the owner skips the country, which is highly unlikely because folks are making money off these systems, they're not going to want to leave it, but just in case, to protect the town, we recommend a decommissioning fund. It should be continuously maintained. It could be a bond or some other instrument that's approved by your village, town, or city. And we just have it set right now to say in an amount to be determined by your municipality, because every system is going to be a little bit different, and you want to make sure that that bond is going to be adequate should you ever have to use it. Okay, site plan application requirements for tier 2 systems. Again, this is not a comprehensive list of every site plan requirement that's in the law, but we tried to pull out the ones that we think are most relevant and unique to this particular technology. So you're going to want that site plan application to include spec sheets for the proposed energy storage system and all of its components, so you know exactly what you're dealing with. You're going to want to see a commissioning plan showing all of the steps that they're going to take to make sure that the system is functioning properly and as designed prior to turning it on. You're going to want a fire safety compliance plan showing everything that they're doing to comply with the fire code and other safety considerations like that. An operation and maintenance manual to make sure that after it is flipped on, even if it was commissioned and working properly, you want to make sure that they have some way to go about making sure that it stays operating properly. Also recommend erosion, sediment control, and stormwater plans. And finally, if I can draw your attention to the very bottom of the slide, number 12, the emergency operations plan, I think, is probably one of the most critical components of the model law. I mean, they're all important, but this is one to focus on. We care very much about the safety of our first responders, and we absolutely recommend that you request an emergency operations plan that includes training your first responders in how to deal with this exact system that's going to be installed. Okay, finally, we go through some special use permit standards that we recommend for tier 2. Unlike solar or wind, it's not so much of a land use consideration here for battery energy storage systems. They don't tend to take up as much room, and they're very easy to hide from sight if you want to. So for setbacks, we're just recommending the underlying zoning district, whatever the underlying zoning district recommends for where it's being built. Of course, you can change that if you'd like, but it's easy enough to just follow this recommendation. The same is true for height restrictions, just reference the underlying zoning district there. Fencing requirements, most of that's probably going to be covered in the electric code too, but you could change it if you wanted to. Maybe you want to have them install fences that look nicer, perhaps, I don't know. Which brings us to screening and visibility requirements. Like I said, these battery energy storage systems don't take up a ton of room or, ruin view sheds or anything like that, but they're also not beautiful to look at. So you want to make sure that the views are going to be minimized to the extent possible from adjacent properties. And you can do this with, different architectural features, earth berms, landscaping, other screening methods, whatever it's going to work for your town to harmonize with the character of the property and the surrounding areas. And then finally, we cover safety. So of course, they all need to adhere to applicable UL listing standards. There are site access safety requirements, working space requirements to make sure that folks can get in there and service the systems if they need to. You need weatherproof enclosures to protect them and folks that may be around them. And then I'm not going to go into the last few here, but of course there's permit time frame and abandonment, what happens if it's abandoned, enforcement, and severability. If you really want to go into the details of that, we're more than happy to send you a copy of the Energy Storage Guidebook to keep on your nightstand for some enjoyment as you fall asleep each night. So just reach out and we're happy to set you up with that. And at this point, I blew through the model law pretty quickly, which is great. And I think it's time to turn it over to my colleague, Candace Rossi, to talk about the model permit and inspection checklist in a little bit more detail.
Thank you, Jen. So like Jen said, my name is Candace Rossi, and I'll be providing you with a summary of the battery energy storage model permit, as well as the inspection checklist, as seen in the battery energy storage guidebook. So next slide, please. The model permit for battery energy storage was created with the similar intent of the unified solar permit, which some people might be aware of, which was launched years ago and has been quite successful across the state, creating a streamlined permit for solar projects. So similarly, we took the same model and started developing it for battery energy storage a few years ago. And this permit establishes requirements for the application review to ensure it is compliant with the code and covering all electrical and structural requirements. It is intended to be a streamlined permit, but because it's streamlined, it doesn't mean that it's a shortcut. We're not cutting any corners with this permit. This is just creating a more transparent process and making sure you're considering all the applicable requirements. It is consistent, predictable, and repeatable. And as was highlighted in the previous section, this permit applies specifically to what we, as NYSERDA, has defined in the model law as a Tier 1 battery energy storage project, which are those residential and small commercial projects. Next slide, please. Here you can see page 1 of the model permit. Here, it provides municipalities with the ability to customize fields such as the fee schedule, payment methods, how the application is going to be submitted, and so on. And also, this is where permitting authorities can set expectations for the timeline regarding the application and review, and this gives contractors a clear expectation on when they will hear back from the permitting authority and can allow all the parties to plan accordingly. So you can see on the screen anywhere that's gray, you can enter in your own information that is applicable to how you and your jurisdiction has done permits previously. So there's still abilities to, it's flexible to meet your needs in your jurisdiction. Next slide, please. So here is this section of the permit that requires information about the actual system that is going to be installed. So the applicant will be required to tell you about the existing use of the building, the system size, how it's going to be configured, the type of battery, and the location. These are important details that will help shape applicable requirements as stated in the Uniform Code that my colleague Bill Obercare will discuss later in the presentation. This also requires the information for the contractor's contact information as well as their license number, and it also requires the same information for the electricians. So you will have all that information with you when they apply for it, so you won't have to go digging for it, and you know who's responsible for the project. Next slide, please. All right, now since the application portion is filled out, the next section of the permit dictates what documents are required to be submitted with the application. There are about 2 to 3 pages of extensive information required as part of the submission, which will ensure that the project is compliant with the code. The documents necessary to submit are pretty, the normal general requirements such as the scope of work and the relevant codes that this project needs to meet, as well as the site and floor plan requirements. So you know exactly where these systems are going to be located and proposed, the electrical and structural requirements, as determined by the National Electric Code and the codes in New York, and the fire requirements as applicable. So all of these documentation will need to be submitted with the application package to ensure that it's in line with the uniform code for these specific projects. Next slide, please. So that was a very general introduction to the model permit. Like Jen said prior, we're always happy to work with your town more directly to assist you on any questions or an adoption of the permit. And now I'll discuss the electrical checklist. So to go alongside with the permit, NYSERDA has published the electrical inspection checklist. And this checklist is for Tier 1 projects as well, which are inclusive of residential and small commercial projects, and covers the electrical requirements as determined by the National Electric Code that's adopted by New York State. So this slide, you can see the different sections that the checklist covers, and that it's rather exhaustive. We've highlighted here specifically some of the signs that are required for these projects that will be checked during the inspection. It is critical for the signage to be correct when inspecting these systems, as improper labeling or signs can cause further problems if there is initial issue with the system. So this checklist lays out, it's also, I think, 3 or 4 pages, each requirement that will need to be met for the project on an electrical basis to ensure that it's in line with the code. And next slide, please. And yeah, so thank you. That was the quick version of the model permit alongside the electrical inspection checklist for Tier 1 systems. And yep, before I pass it to my colleague Bill, I just want to reiterate, which I'm sure you'll hear 1,000 times during this presentation, this is really just an introduction to these resources, and we're happy to work with your town directly in adopting the model law and energy storage permit, or if you have any questions at all. And with that, I'll pass it over to Bill.
My name is Bill Oberkar. As Ian said, I'm a project manager on the clean energy siting team at NYSERDA, and I'm going to do a very high-level overview of the 2020 New York State Uniform Codes as they relate specifically to energy storage. Next slide, please. All right, so this is a very high-level overview of kind of the universe of safety standards that apply to energy storage systems. Going chronologically, our first that we see here is UL 9540, which is a listing standard for energy storage systems. What that standard says is that all of the components of the system are certified to work together. So all of the components in the system harmonize with each other. And then the 9540 listing also has several other UL listings for the individual components of the system under its umbrella. And this says 2016. It's the beginning of our journey through energy storage safety here, but it's also the end, because a new edition of UL 9540 was released in February of 2020. So there's been an update to that since the first edition just last year. And the most notable thing about that update is that it includes, down here we see 2017, UL publishes the first edition of 9540A. So the updated edition of the 9540 listing includes 9540A, which confused a lot of folks, myself included, for a long time, exactly what the difference between those two things was. So 9540 is a listing, a certification for the equipment, that all of the pieces, all of the components harmonize with each other safely. And then 9540A is a large-scale fire testing, a large-scale fire test, rather, I'm sorry. It's going to be a test method to evaluate the system safety in the event of something called thermal runaway. What you're going to get at the end of 9540A testing is data that explains how your system at the cell level, the module level, the rack level, or the installation level is going to behave in the event of thermal runaway, which is essentially exponential overheating of a particular piece of the system. So we are now on edition 4 of UL 9540A, and as I mentioned before, that is going to be rolled in now to edition 2 of 9540. And I promise I will not use those numbers too much going forward, try to get it out of the way all at the top just to make sure I win everyone over. And then in 2018, we have the International Code Council introduces Chapter 12 to the International Fire Code. That then kind of inspires the release of NFPA 855. And I saw some questions in the chat regarding NFPA standards. NFPA 855 is really more or less the basis of the energy storage chapter 1206 of the Fire Code for New York State. And then also in 2019, an exciting year, UL published that fourth edition of 9540A. And we also got the International Code Council's drafts of the 2021 International Fire Code and International Residential Code. And those drafts have been incorporated into the 2020 Uniform Codes. Next slide, please. All right. So in 2019, to bridge the gap between the 2018 Uniform Codes and the 2021 drafts, the New York State Uniform Code Council adopted the 2019 Energy Storage System Supplement. And that incorporated a lot of elements from the NFPA 855, as well as some elements of the draft 2021 code. So now in 2020, the code cycle went into effect, and from I believe May of 2020 on, we're dealing with the 2020 New York State Uniform Codes. That's going to include the 2020 residential, building, and fire codes. Those are applicable across New York State without the need for local adoption, with the exception, of course, of New York City. So these codes are going to be the baseline rules for any jurisdiction in the state except for New York City, and then jurisdictions may exercise their home rule authority to make regulations more stringent than they appear in the statewide documents. Next slide, please. Let's start with the 2020 residential code. Crucial here are the size, location, and separation requirements. We have a unit cap at 20 kilowatt hours per unit. For reference, the standard unit in a Tesla Powerwall, just using that because I feel like folks are probably most familiar with that, that's going to be 13.5 kilowatt hours, so well under the 20 kilowatt hour per unit threshold set by the residential code. The location on residences is attached or detached garages. Exterior walls are within utility closets and storage or utility spaces. You can have up to 40 or 80 kilowatt hours in aggregate capacity, depending on the location of the installation. So when you see 20, 40, 80 here, 20 is the limit per unit. Multiple units make up the installation or the aggregate capacity. So you can go up to 40 kilowatt hours in aggregate or 80 kilowatt hours in aggregate if it's on exterior walls. And that's what that's saying. So it's important to understand the distinction between the per unit capacity and the aggregate capacity. The aggregate capacity, again, being the total capacity of the system with all of the units involved. Each unit must have a separation of 3 feet from other units, as well as doors and windows, according to the code. Fire resistance rating requirements are for the walls and ceilings of rooms and areas containing energy storage systems. Rooms and areas not exactly defined, so this is up for some interpretation by code officials, as a lot of code tends to be. And then we see right there at the bottom, protection from impact. This is primarily going to be vehicle impact protections in indoor garages. So if you have a system inside your garage, you're going to want a bollard or two there to be able to make sure that your vehicle is not running into that system. Next slide, please. All right, let's move on to the fire code. Two big things that you see exclusively in the fire code are listed here: the hazard mitigation analysis and the large-scale fire testing. These are both going to kick in at 600 kilowatt hour mark. So systems greater than 600 kilowatt hours are going to trigger both of these requirements. Also important to note that that 600 kilowatt hour figure is what the rationale behind the difference between tier 1 and tier 2 systems in the model law. So that 600 kilowatt hour threshold for the aggregate capacity is a trigger for a few things. So good to keep that number in mind. The hazard mitigation analysis is essentially just going to evaluate the consequences of ESS malfunctions and failure modes. And they're going to have an approval contingent on demonstration that consequences of the system failure, whether they be fire or gas, will be contained, controlled, or limited by the system protection. So just no surprise, the hazard mitigation analysis wants to see that all the hazards are properly mitigated. Onto large-scale fire testing, which was the 9540A test. The point of that test is to demonstrate that fire will not spread to adjacent systems or areas. And that's why you have that 3 feet separation between unit requirement. It would theoretically be possible to test out of that size and separation requirement with the 9540A test data, provided that the AHJ, or authority having jurisdiction, signs off on that. Testing results to that end will inform necessary protections and requirements. And this, as I said before, will be required for everything over 600 kilowatt hours of aggregate capacity, but could also be utilized to seek exceptions like for size and separation, as I mentioned. Next slide, please. Right. A little more on the fire code. Let's talk fire remediation. So the energy storage system owner is going to have the responsibility of providing a fire remediation team to relieve the first responders and notify the local fire department as needed. So in the event of a failure, you don't want to have your fire department hanging out there to make sure there is no reignition. So the energy storage provider will have some folks there to make sure that the fire department is alerted in the event of reignition or a second emergency. Peer review requirement is also built in the code. This gives the AHJ the authority to have the energy storage system owner retain and fund services of an approved peer reviewer. So that's going to be a professional engineer or a registered architect to, primarily to review plans, design, make sure the system appears to be code compliant. But again, what that peer reviewer does is somewhat subject to the interpretation of code by the AHJ. And then finally, we've got commissioning, decommissioning, and O&M, which have been touched on briefly, so I will not belabor it. The O&M manual is going to have to be provided to the jurisdiction before commissioning and maintained at an on-site location. And decommissioning plans, as mentioned earlier, ought to account for the removal of end of life of the system or in the event of fire or other damage that renders the system unusable. Next slide, please. All right, I've got a few tables here that we'll take a look at. So this table here establishes technology-specific safety requirements. It's going to be based on the risks associated with each of the different technologies. We could just take a few here. We'll go to the first one, 1206.13.1, exhaust ventilation. You'll see that a lead acid battery will need that and a lithium ion will not. And the reason for that is that you can expect gas discharge from standard operations, normal operations from a lead acid battery, while during normal operations, a lithium ion battery will not off gas. And then for explosion control, you'll see that a little bit more uniform across the board, where all technologies except for flow batteries are subject to that requirement. And then you'll see thermal runaway as well. That's the 9548 test again, where again, all technologies except for flow batteries are going to be subject to that as well. Next slide, please. Okay, so we've got some location-specific requirements as well. I believe for folks who tuned in a few weeks ago, Paul Rogers also went over some of these. But we've got essentially 4 different classifications of locations for energy storage. The 2 indoor types are dedicated use buildings and non-dedicated use. A dedicated use building is exactly what it sounds like. It is a building or structure that serves no other function than to house an energy storage system. A non-dedicated use building would be something like a 1 or 2 family home where we've got a power wall or whatever home system in the garage or maybe in a utility closet somewhere. That's going to be a non-dedicated use building because you also have folks living there. And for outdoor installations, we have outdoor near exposures, which if you had, say, an energy storage system on the exterior wall of your home, that would be outdoor near exposures. And as I said before on the previous slide, that would require at least a 3-foot separation from any of those exposures, unless you test out of that with the 9540A large-scale fire test. And then finally, you'll have the outdoor remote system. These are the ones that are, I believe, at least 100 feet away from anything else. They are outdoors, and they typically will pose the least risk to the immediate surrounding area. Next slide, please. Let's take a look through another table for compliance as it relates to the 4 types, or these are just going to be the 2 types of indoor. So we've got the size and separation is a crucial one. That's one that you could potentially test out of with the 9540A test. That is going to apply to both dedicated and non-dedicated. But then you'll see the maximum allowable quantities. That's that 600 kilowatt hour figure I emphasized before. That is not going to apply in dedicated use buildings, but it will apply in a non-dedicated use building. And then as you can see going down the line, the rest of the requirements here are pretty similar for dedicated and non-dedicated. Obviously, you would not have dwelling units and sleeping units in a dedicated use building. So, requirement is not applicable there. Next slide, please. Right, and now we're gonna take a little walk through with the outdoor installation requirements. Little bit different here, but putting it in the context of remote installations or something that could be, say on the wall of your house. I hope this would be pretty straightforward for folks to be able to understand. The size and separation and maximum allowable quantities, both are not going to be enforced for these outdoor installations for remote. Again, those are the ones that are going to be at least 100 feet away from anything else. And then you can see the rest apply across the board. And some of these are going to have a little bit of some extra requirements, so to speak. Like I believe it's fire suppression systems need to be listed to NFPA 15, I believe it is, and I think that's what that D means there. But you'll see if folks have a reason to get into the code, that those references will be a part of these tables where they do appear in the code. Next slide, please. And I believe I'm going to pass this back over to my colleague Jen to take us home, and we'll look forward to answering any questions that folks have.
That's right. Thank you, Bob. So just a quick recap, so we leave plenty of time for Q&A. Just know that in our energy storage system guidebook, which is available for download on the website, and we're also happy to send you a hard copy if you prefer, or even multiple hard copies, just let us know. Included in that guidebook is the law that we went over, the model zoning law, the model permit, and the inspection checklist, as well as a copy of the 2020 New York State Uniform Code that Bill just went through. So that you really have everything all in one book that you could possibly want to know without having to jump back and forth between our guidebook and then go dig up the fire code somewhere else. It's all right there for you. And again, we like to continuously offer our services throughout our presentations in the beginning, throughout, and at the end. So there's always the invite. We're happy to work one-on-one with your municipal boards, your local officials, anyone who has questions. We'll provide free technical assistance to the best of our abilities. And in addition to that one-on-one work, we're also always happy to schedule trainings, much like this one. We offer free accredited trainings for code enforcement officials and also for planning and zoning board members. So if there's anything you take home tonight, it's the most important thing is reach out to us if you have any questions or concerns or training needs. So a couple helpful links here. I'm assuming we can send the slides around after. Feel free to visit those links for more info. Actually, I'm going to wait 1 second before we take Q&A because before we start losing people, I want to make sure that we tee up the next webinar in the series, which is decommissioning and end-of-life considerations on Wednesday, June 16th. It will be number 4 of 5, so stay tuned for the rest of those. And now I'm going to do my best to try and sift through some of the questions that came in and answer the ones we can't, and hope to connect perhaps one-on-one after the fact for the ones that we're not able to answer right now. So the first question that came in states, even though lithium ion are the predominant type of energy storage today, how can municipalities account for different chemistries and technologies in their zoning law? Are there differences between technologies that would warrant a zoning law specific to lithium ion, or is more general language advisable? I would say I think our zoning law covers all of them. I don't think it needs to be lithium ion specific. It's not as it's designed right now. It should pretty much cover any type that comes in, even though you're more than likely going to be seeing lithium ion coming in. If you wanted to, you could try and maybe include some language that specifies they have to adhere to the chemistry specific requirements that are in the fire code, but they're going to have to do that anyway because it's in the code and it's applicable across the state, everywhere except New York City. So perhaps that question was answered a little bit more after you saw some of the charts that Bill was presenting. I think the fire code is really where the different chemistries are addressed. The zoning law is more about where you're putting them, how you're screening them, requiring that your first responders get trained and things like that. Okay, so another question. Is fire safety testing for energy storage systems done through independent labs like Intertech or UL or by some other means? So the answer to that is actually fairly simple. Testing is conducted by what are referred to as nationally recognized testing laboratories, NRTLs, and you might want to pronounce that NERTL. The next question, if you have a 20 megawatt solar project being permitted via seeker that is co-located with a 5 megawatt battery, the battery would also be permitted via seeker, correct? And the answer is yes. They'd be permitted via seeker and any existing local land use requirements like special use permit, site plan, et cetera, that you've seen in here. However, in this specific example, it's interesting that this person who submitted the question chose to use a 20 megawatt solar project and questioning if that would be permitted locally or not. Technically, they could opt in. They're right at the threshold for being able to opt into the state level siting process through ORES, in which case the 5 megawatt battery that's attached to it would go with it, but they absolutely do not have to do that. And it would be permitted at the local level by default if they don't opt into ORES. Okay, next question. Generally speaking, how well trained and prepared are municipal code enforcement officers at this point to inspect energy storage systems? So it's hard to say for sure. I don't think we've reached everyone across the state just yet, although we're working on it. If you know some that need training, feel free to send them our way. But I can say that we are committed to ensuring that training is available to everyone who wants it. We've worked pretty closely on multiple occasions with the New York State Building Officials Conference chapters to conduct trainings at their conferences and events. And of course, those come with credit, which everyone always likes, among other organizations as well. We've been doing these types of trainings for energy storage since 2019, and we're happy to continue to do so. Okay, how does the battery energy storage system model law align or differ from the New York State Uniform Code? So if we had maybe gotten into the model law in a bit more detail, you would have seen that throughout there are clauses that refer users back to the New York State Uniform Code. So I would say in that respect, it is perfectly aligned because it totally incorporates it, right? The law basically puts additional local requirements on top of what someone would already be required to do according to the New York State Uniform Code. The law is more about harmonizing your zoning and dealing with the visual land use and community impacts of systems, while the codes are dealing more directly with safety. A lot of the things that you saw in the model law with respect to safety are sort of reiterating what might already be included in the Uniform Code. One part that sticks out to me, which I called your attention to earlier, is that emergency response plan is not an explicit requirement in the fire code, but we absolutely recommend including it in your model law. So that's another good argument for actually adopting an energy storage model law and not just relying on the Uniform Code to guide all of your decision making with permitting. Okay. Someone stated that in the last webinar, they thought that our fire consultant, Paul Rogers, was suggesting a 100-foot setback for tier 2 systems. So there's something that 100-foot setback is not, we're not recommending necessarily a 100-foot setback for every system, but that is the cutoff after which large-scale energy storage system would be considered a remote installation, and therefore some of the fire safety requirements are relaxed at that point. So it's not a hard and fast rule that they must be set back that far. It's just that if they are, there's less of a risk to adjoining properties. And so again, they might have slightly more lenient requirements in the fire code. Again, some of that was in the charts that Bill was going through. Okay, I am going to pull in one of my colleague Bill for this next question here. It's going to be a doozy, but it's also one of your favorite topics, Bill. Is there a different permitting process in New York City for large energy storage projects?
Thanks, Jen. Yes, there is. As I mentioned as I was going through the applicability of the uniform codes, New York City is an exception. New York City has its own rules for every size of energy storage project. Those rules are going to come from the fire department and the Department of Buildings in the city. The fire department actually just released an updated fire code. The easiest way to find that for folks who are interested is just to type in draft NYC Fire Code in Google. It will be likely the first or second result that you see. And I'm bringing that up because Chapter 608 of the draft code deals with energy storage systems. And for folks who may be interested, there will be a public hearing on June 15th at 11 a.m. on the draft fire code, and a public comment period that goes until end of day June 18th. And if folks are interested in submitting comments or just maybe even attending the public hearing and learning about what New York City is doing and why, I would encourage folks to attend those. To answer your question though, yes, there is a different permitting process for all energy storage projects in NYC. Unfortunately, we don't have enough time to go into all the nuances of those differences here tonight.
All right. Actually, Bill, don't go anywhere just yet. I'm going to toss another one your way, if you don't mind. Okay, so it's a 9540, 9548 question. This person asks if listed 9540 equipment has been put through 9540A testing. So can you assume that anything that's listed on 9540 has also undergone a 9540A large-scale fire test?
That's a great question, and it's quite a hair to split. So the 9540A fire testing was included in version 2, edition 2 of 9540, which was just released in 2020. So edition 1 that was released in 2016 did not include the 9540A testing. So no, just because you see 9540 does not mean that the product has gone through 9540A testing unless you see 9540 edition 2. A vast majority of 9540 listed projects on the market have been certified to 9540 edition 1. That said, a lot of those products have pursued the 9540A testing separately. So in addition to their 9540 listing, they went and got the 9540A test kind of a la carte. So no, you can't always assume that if something is 9540 listed, it has been put through 9540A testing, unless you see that edition 2 on the 9540 listing.
I'm going to keep you here one more time, at least one more time. And this is a very good question. I know it's something we've talked about a lot internally and discussed. Is there a right or wrong pass fail with the results from large scale fire testing through UL 9540A?
No, is the simple answer to that question. And as I, briefly went over before, edition 1 of 9540A was released in 2017, and we are on edition 4 as of 2019. So that kind of pass-fail qualification has been kind of obfuscated throughout the editions, but edition 4 is actually the best edition for that. So what 9540A is a battery of tests, essentially, that you're putting the battery through. And then in the 9540A edition 4, a lot of those tests are going to be listed as pass-fail individually, which is helpful. But that is not to say that because you've gone through 9540A testing, you have passed all fire testing concerns, and you are now kind of have this stamp to do whatever you want. That is not the case. That edition 4 still needs to be reviewed by a fire protection engineer, or at least a professional engineer.
Thanks. I'll give you a speaking break for a second here, and I'll take the next one about it. Only because one of my colleagues was so kind as to already write out a response for me. This other question, again, about 9540, is asking if it needs to be completed after the energy storage system is already built and installed. And the answer is a clear no. That testing would happen far before any system would be installed. For a little bit more clarity on how that test works, again, conducted by a nationally recognized testing lab. It's not like they're lighting these systems on fire on site and location. It's done in a lab on like a representative system that would be installed, right? And they start out, the different levels of the test, they start out at the smallest level, testing the cell. If everything goes well from there, you move on to the module, do some fire testing on that. If everything goes well, you move on to the unit, and the unit in its intended type of installation environment. And that the installation level testing in that case would include all of the fire suppression and other safety equipment that would be used in a particular site as well. So if you need some sort of fire suppression system, that would be included in the installation test as part of 9540A. Bill, if I missed anything there, feel free to jump back on. Otherwise, I'll try to move on to, I think we have time for maybe one more question. And if anyone submitted a question and we don't get to it, there's a lot here and it's tough to pick on when we're short on time. Again, feel free, our email's right there on the screen. Feel free to send us an email after the fact if you feel we didn't address your question adequately. Okay, trying to pick another question here. Someone asked, for municipalities that don't have zoning, what is the recommended setback? I'm not sure that you could enforce setbacks without zoning. free to adopt some if you're interested. If you're not, I would think that you would just have to defer to the requirements that are in the uniform code, those fire safety requirements that have, it clearly outlines. If you want to go through it in great detail, again, let us know if you want us to send you a copy of the storage book. It includes the whole copy of the code in the back, but there are some setback requirements in there where they can't be near other structures. It's not 100 feet. I think it's 10 feet from other structures that could potentially catch fire. And there's like the 3-foot separation between different modules of the system itself. So there are some things already in the code. And I assume if you don't have your own zoning adopted, that would be any of the recommended setbacks. Otherwise, like we said before, for municipalities that do have zoning, we recommend just defaulting to the underlying zoning for whatever zone it's going to be built in, just like you would for any other building, for example. Okay, so one other one, I'm gonna have, this will be the last one, I think, for tonight, because we're just about at time. I'm gonna have Bill, if you want, pop back on here. Everyone's loving these fire safety standards. Are there also applicable NFPA standards aside from UL? So maybe if you could just clarify the difference between all these different standards and acronyms that we've been referencing throughout.
Sure, that's a great question. And one, I don't have them all memorized, and two, there are a lot of them, so it would be a bit unwieldy to try to list all of them. But basically, where there is a UL requirement or an NFPA standard necessary to meet the code will tell you that. Like I believe the fire suppression system has to be in accordance with NFPA 15. I think explosion control is NFPA 68 and 69. And then components of a 9540 system, I think the cell is UL 1640. And then the inverter is, I think, 1743 or something. UL. So they're all, yes, there are a bunch of them, but in order to find out, which ones that you need to pay attention to for the project that you're looking at, the code is going to be the best place to just find out what you need to know on a case-by-case basis, because it would be awfully tough to memorize them all.
Yeah, sure. And fair to perhaps note that the chapter in our fire code, chapter 1206, is the fire code. It's adapted from NFPA 855. So would it be fair to say that they're sort of equal or, sister codes, if you will?
Absolutely, yes. NFPA 855 is kind of the basis for energy storage uniform codes in New York, and I think California has adopted a version of it too. And I don't suspect other states will be too far behind.
Great. Okay, I know that there ended up being a few that we probably didn't get to. Again, I invite everyone to shoot us an email, and we're happy to follow up with you after the fact. We want to give everyone back the rest of their nights. Maybe you've been waiting to eat dinner. Enjoy. And again, I popped up on the screen here our flyer outlining the next webinar. So don't forget to register for those and attend. And if you can't, we're going to post the recordings on our website. So have a good night, and thank you, everyone.